Alright, section 11.3 is about the dot product of two vectors. Our objectives are to use the properties of dot products of two vectors, to find the angle between two vectors using the dot product, find the direction cosines of a vector in space, find the projection of a vector onto another vector, and use vectors to find the work done by a constant force. The dot product. In this section, you'll study a third vector operation called the dot product. This product yields a scalar rather than a vector. Recall that when you add two vectors together, the result is a vector. If you perform a scalar multiplication, the result is a vector. Now the dot product is no longer a vector, so please don't get them confused and start writing i's and j's or using the angle brackets when you calculate the dot product. The dot product of two vectors is found if you have vector u with components u1 and u2 and vector v with components v1 and v2, the dot product is found by multiplying the corresponding components and adding the result together. This is a scalar, it's no longer a vector. If the vectors are in space with the three components, you multiply the corresponding components and add the three results together to get the single scalar dot product. Here's an example where we're given vector u with components 2, -2, and vector v with components 5, 8, and vector w with components -4, 3. Find each of the following. You can pause the video now, try these on your own, and then come back to check your result. For part A, u dot v, the dot product of u and v, we take u, the corresponding components, we're going to multiply 2 and 5 together, and we're going to multiply -2 and 8 together. We're going to add those results together to get -6. Notice this is no longer a vector, a single number, single scalar, -6. For part B, we want to do what's in the parentheses first. Use the dot product, and then we're going to multiply the dot product times W. Well, the dot product is -6, which is a scalar. Now this is a scalar multiplication, you're going to multiply vector W by -6, and the result is going to be a vector. The dot product part was a scalar, and then the second part is the scalar multiplication. And then finally, C, we want to find the dot product of u with 2v. Now you can find 2v first and then do the dot product, or we can use this property, find the dot product and multiply the result by 2. When you do that, you get -12. That is a theorem, special theorem. Now you could do it the other way and confirm that you would get the same result. Here's an additional example I'll work through with you. We want to find u dot v. If u has components 4, 10, and v has components -2, 3, let's find the dot product. All right, so what we're going to do is u dot v. We're going to multiply the corresponding components first with the 4 and the -2, 4 times -2, and then we're going to add 10 times 3, that will give us a -8 plus 30, which would be a single scalar of 22. That would be the dot product of u and v. Now we use that dot product to find the angle between two vectors. Theorem 11.5 is a theorem used to calculate the angle between two vectors. If theta is the angle between two non-zero vectors u and v, then the cosine of the angle theta is u dot v, the dot product in the numerator, divided by the magnitude of u times the magnitude of v. And we recall in the previous section how we find the magnitude of a vector. Now, when you get this equation, cosine of the angle theta will equal some value. You would then find the inverse cosine of that value to determine the angle theta. Here's an example. We have vector u, v, and w and z that are given. We want to find the angle between these pairs of vectors. First, u and v. Using the formula cosine theta equals u dot v divided by magnitude of u and magnitude of v, the dot product in the numerator, we are going to multiply 3 and negative 4. That gives you the negative 12, negative 1 and 0, and 2 is 4. The dot product, we're going to simplify that, divided by the square root of 14 over the square root of 20. Remember how we find the magnitude of u. The magnitude of u is 3 squared plus negative 1 squared plus 2 squared, the square root of all of that. And we get this result. Now to find the angle theta, you want to use you can simplify that and use a calculator to find the angle theta. You would do the inverse cosine of negative 4 over the square root of 70. Put that in your calculator and make sure you're in radian mode. Check that so that you get the angle is approximately 2.069 radians. Now, since the u dot v is less than 0, it's a negative. That usually indicates that the angle between them is up to, so it's greater than 90 degrees. Here's for part B, we want to find the angle between U and W. So we're using the same formula, just replacing the V with W. Do the dot product in the numerator, divided by those magnitudes. In the numerator you get 0, and then 0 divided by anything is 0. So the cosine of the angle theta is 0. What angle is cosine equal to 0? You could do inverse cosine of 0. Either way, you'll find that the angle is pi over 2. If you're in degree mode, it's going to show 90 degrees. Whenever the angle between the two vectors is 90 degrees or pi over 2, we say that those vectors are orthogonal. And in fact, that is going to happen whenever that dot product is 0. For part C, we want to find the angle between V and Z. Do the dot product of V and Z divided by the magnitudes. So we see that the dot product is negative 10 divided by the square root of 100. So for this one, we find that the cosine of the angle theta is negative 1. And therefore, the angle between the two vectors is pi, or 180 degrees. And then we can see that V and Z would be parallel, and V would be going in the opposite direction of Z and twice as long. Here are some additional examples that we can find the angle between the two vectors. We have the angle bracket notation, we have vectors in space and the plane, and we want to go ahead and find the angle between the two vectors using the dot product. We want to find we know that the cosine of the angle theta is equal to the dot product u dot v divided by the magnitude of u and the magnitude of v. We're going to do the dot product first. The dot product of u and v is 3 times 2, which is 6, plus 1 times negative 1, so it would be 6 minus 1, divided by the magnitude of u. The magnitude of u would be 3 squared plus 1 squared. That would be the square root of 10. And the magnitude of v would be 2 squared plus 1 squared. That would be the square root of 5. Now what I tend to do when I use a calculator to find the angle theta, is I don't do too much simplifying. The cosine of the angle is going to be 5 over The square root of 10 times 5, that's the square root of 50. Now you can simplify that, but for now, that's not as important as finding the angle. And what I do is I find the inverse cosine of 5 divided by the square root of 50. Make sure you put all of that in one set of parentheses. And if you're in radian mode, you should get radians of approximately 0.785. If you're in degree mode, the angle between those two vectors is actually 45 degrees. So the angle in radians would be exactly pi over 4. Let's find the angle between vectors u and v for part B. Again, we're going to find the dot product of the of u and v. So cosine of the angle is equal to the dot product in the numerator. 3 times 2 would be 6. 2 times negative 3 would be negative 6. And the component here is 1, but you can also think of this as 0k. So 1 times 0 would be 0. And, I'm going to just skip this denominator for a second because you will see that the numerator ends up being 0. So it doesn't really matter what is in the denominator because the cosine of the angle theta is equal to 0. And if you do the inverse cosine of 0, you will find that the angle ends up being pi over 2 or 90 degrees. So in this case, vectors u and v are orthogonal. Now let's look at the last example, finding the angle between u and v. It's the dot product in the numerator. 2 times 3 over 2 is 3, and 18 times negative 1 over 6 is negative 3, divided by the magnitudes of u and v. Again, I'm not even going to bother working through that because the numerator ends up being 0. So the 0 divided by whatever ends up being in the denominator, you will find that the angle is pi over 2, also 90 degrees.